All right, so the last part of aerobic respiration is going to be the electron transport chain. And our electron transport chain is going to play a role of harvesting electrons from our electron carriers. So in the Krebs cycle and in glycolysis, we had all of these electron carriers we made. And so just a reminder, we had 2 NADH coming from glycolysis, we have 8 NADH coming from the Krebs cycle, we have 2 FADH2 coming from the Krebs cycle. And all of these electron carriers are going to be headed here to the inner membrane, and they're all going to be dropping off those highly charged electrons they're carrying to the beginning of our electron transport chain. And so here, just to get our bearings, I've drawn my mitochondria. And this section right here that I've bolded and kind of put a box around, that's what we're looking at zoomed in here. And I've drawn a kind of basic lipid bilayer and built in some of the molecules that we might find in the electron transport chain. So our electrons are going to be dropped off here at this electron transport chain, and they're highly energized at this point in time. They've come off a really high energy molecule, and the high energy electrons are going to pass through the electron transport chain. And this is going to be a reverse of what we saw in photosynthesis. So this time, our electrons, as they're dropped off, we are going to be taking and driving hydrogen ions through the inner membrane, and they're going to accumulate in the inner membrane space. And so those electrons that are going to be bouncing through our electron transport chain are going to be providing energy and pumping our electrons into, my apologies, our hydrogens into the inner membrane space. And they're going to be gathering up here and creating a concentration gradient, just like what happened in photosynthesis. So as they go through, they are dedicating their energy to pumping hydrogen ions through. At the moment, please don't worry about where these hydrogen ions are coming from. Hydrogen ions are pretty easy to come by, so don't get hung up on where they're coming from. Keep in mind that our electron carriers, when they're all said and done and they're free of their electrons, are also going to be free of their hydrogens. So our FAD plus is going to have dropped off its electrons. Our NADH is going to have dropped off its electrons and is going to be headed back as NAD plus. So those hydrogens it's carrying are also going to be dropped around. And so these hydrogens are going to be available to move through our inner membrane proteins here and make their way into the inner membrane space. And this pump is going to work against the concentration gradient. So our hydrogens are going to be at a greater concentration here. So hydrogens are at a greater concentration within the inner membrane space. So in our first step, our electrons are dropped off at the electron transport chain in the inner membrane of the mitochondria. Those electrons then are going to provide energy to pump hydrogen ions into the what's called the inner membrane space. And that pumping off is going to cause hydrogen ions. In step 3 here, we'll say hydrogen ions build up to high concentration in that inner membrane space. This is all number 3 here, separated from our hydrogen ions. And just as before, those hydrogen ions that are existing in this inner membrane space are going to take any path they can to get out because they're at greater concentration. And the path they're going to take is through ATP synthase. Notice I've drawn our ATP synthase kind of facing the other direction this time. Our hydrogen ions are going to move through this, and that proton motive force is again going to provide the energy needed to take our ADP, phosphorylize it, and turn it into ATP. Right? Can add in our last little bits of lipid bilayer here. And we can put our step 4 down in here, and our step 4 is going to be that ATP synthase uses the energy from our proton motive force. So step 4, ATP synthase utilizes the energy from proton motive force to phosphorylate ADP, making ATP. And we should put our little explosion here. All right. We'll do our counting in just a moment. But then these protons that are moved into here are then available to pump back into the inner membrane space. Now we have one more thing that we have to talk about. And maybe I should have saved my numbers, but that is when our electrons get to the end of the electron transport chain. If you remember in photosynthesis, I told you that having free electrons was not a good idea. They're like wild toddlers, and if you give them an empty space, they're going to end up destroying it. So these electrons are going to need to be picked up by something. And if you consider where they came from to begin with, they came off of water to start with, so it would only make sense that we're going to put them back on water. So some of these hydrogen ions that are accumulating here are going to be picking up an electron. So a hydrogen ion plus an electron is going to equal just a plain hydrogen. And if we do that a couple of times, we are going to be able to then combine that with an oxygen molecule. Where did the oxygen molecule come from? Well, this is actually why you breathe. So our combination of 2 hydrogens and an oxygen here is going to produce H2O. And H2O was one of our initial products we talked about being a waste product. And we also talked about the need for oxygen. So our oxygen is being used that we breathe in to pick up electrons at the end of the electron transport chain. And it has a very special name, and that is the final electron acceptor. I hope you can hear a really deep voice in final electron acceptor. The reason you breathe is so that you can pick up the electrons at the end of the final electron, or the electron transport chain, as a final electron acceptor. So our oxygen becomes our final electron acceptor as it joins with 2 hydrogen ions and 2 electrons to pick up any of these electrons that are coming off the electron transport chain to prevent damage to our cells. Now, this is so important that if we were to stop breathing oxygen, then the electron transport chain would cease. We would not be able to continue to pick up the electrons, and we would not be able to make enough ATP. And that happens pretty quickly. You can't hold your breath and be without oxygen for very long at all.